So we'll finish up section 4 here. We're talking about binomial probability, which is where you have basically the probability of something happened and the probability of something not happening. So let's look at a few more examples. Let's see what we got here. Okay. So this is a problem out of your book, and it asks a number of different questions. It says a fair dice is rolled 3 times. A 4 is considered success while all other outcomes are failures. Find the probability of each number of successes. So this is so we're going to look at a few of these cases. So the first one is, what is the probability of getting one roll of 4? And I'm going to, instead of putting a 4 here, I'm going to put a little 4 little dots so we don't get confused about what we're talking about. So so what's the probability of getting 1 4 out of 3 rolls? So remember the probability formula for binomial situations is the probability of x successes is equal to, you take n, we have n trials, we have x successes, that's just the combination formula. You have the probability of success raised to the x power and the probability of failure raised to the n minus x power. So all we need to do is figure out what x, n, and p is. We can always, once you know p, you can figure out what q is. So in this case, we're talking about 1 success. We're getting 1 4 out of 3 rolls. So the number of trials is 3. So n in this case is 3. N is always going to be equal to or greater than x. Can't be the other way around. So if there are 2 numbers, the bigger number is n and the smaller number is x. If they're this, that's usually the case. The probability of success. So what is the probability of getting a success? We looked at that earlier in the chapter. If we go back all the way to the beginning, we talked about flipping a coin or rolling a dice, and we said, you know, the probability of getting a 1 in this case was 1/6, and the probability of not getting a 1 was 5/6, because there's 6 sides to a dice, and only one of them is a success, and the other 5 are failures. So the same thing applies here. It's the probability of success is going to be 1/6. And as a consequence, the probability of failure is 1 minus the probability of success, which is 5/6. So we have everything we need. Now we just need to plug it in. So the probability of getting 1 4 out of 3 rolls is going to be, so we take n things, n is 3, 1 at a time. Our probability of success is 1/6. We only have 1 success. And then we take the probability of failure and we raise that to the n minus x. So let me move this one down a little bit. So we're going to have 1/6 to the first power, and 3 minus 1 is 2. So you get 5/6 to the second power. Second power, not 5th power. So I want you to pull out your calculators and do these calculations, just so that you know how to do it, or you know that you don't know how to do it, so you can ask me how to work it on your calculator. Let me get my calculator out. So, does anybody remember the rules as far as combinations are concerned when you take things 1 at a time? It equals 3. Yeah. So anytime this is 1, taken 1 at a time, it's the number of times that you are things you're choosing from. So the first one is just going to be 3. And that one way to remember that is Pascal's triangle. If you draw out Pascal's triangle, the outside are always ones, and then the next term in is always the number of the row it is. So because you always have 1 plus 3 is 4, 1 plus 4 is 5, so just it continues on down like that. So this particular combination arrangement is the third row because we have 3 things and it's 1 in. So when you go in one row, it's this thing. So it's always if you took 7 things one at a time, it would be 7. If you took 25 things one at a time, it would be 25. So if you ever have 1 as the second digit, it's the first digit. Now you see the symmetry over here, so that you have a 4 over here and a 4 over there. So as a consequence, this is 6 things, or well, not 6. This is 1 minus the total number. So if you have 7 things taken 6 at a time, that's equal to 7. Or if you had 25 things taken 24 at a time, that's 25. So if the first digit, the second digit is 1, then it's the number. If this is 1 less than the n in the calculation, then it's also 7. And as a consequence, anything, I'll just put x, so this can take on any value, taken 0 at a time is 1. So, 100 things taken 0 at a time is 1. And on the other side, if you take x things x at a time, then that's also 1. So if you have 100 things taken 100 at a time, the answer is 1. So either 0 or the number, if these numbers are the same or the second number is 0, the answer is always 1. So that saves you some time. So if you guys online, if you can put your answer for what you got when you multiplied this out. And I'll do my calculation, see what I get. 3 times that times. Yep, that's the right answer. Let's see if anybody's put in an answer. Harmony. So how about the rest of you guys? The question is whether they trust harmony or not, or if they got the same answer. So did anybody get the same answer as harmony? 0.3472. Yep. So that is the correct answer. Okay, so let's look at the next one. How about if you get 2 4s? So I'm going to put my little 4 dots again. So x is, this number of successes there is 2, and the number of trials is still 3. The probability of success is still 1/6, and it's the same for the probability of failure. It's the same. So I'm not going to plug them into the equation. I'll let you plug them into the equation. And again, you should be able to use, to evaluate this, which is not going to be 3 things taken 1 at a time, it's going to be something different. You should be able to use this information, this fact. To do it, you shouldn't have to actually calculate that. So this ended up being 0.347. So what that means is if you roll a dice 3 times, there's a 0.347 probability that you'll get a 4 one of those times. It's not at least one of those times, it's just one of those times. So maybe the first time you roll it, maybe the second time you roll it, the third time you roll it. Those are the 3 possible cases. And so about a third of the time. I had to get some dice or something, we could try that in class, except people online couldn't do it. There's probably some app that you can do, like a rolling the dice app. What's that? Just get dice? Yeah. Okay, let's see if anybody's come up with an answer yet. Not yet. Okay. So I'm gonna do my calculation here. So do you? Yeah, I'm sure there's an app. There's an app for everything. Now, just from a general perspective, would it be more probable or less probable to get 2 4s out of 3 rolls than 1 4 out of 3 rolls? Just thinking about it. Do you think it would be more probable or less probable to have this occur than to have this occur? What's that? Yeah, less possible because you're getting 2 of the same thing. It's kind of like there's this thing about. Has anybody ever heard of the term entropy? Yes, no? Where did you hear it? What's that? Physics? Oh, yeah. Yeah, entropy is a physical property of stuff that measures how disordered the physical state is. So if you took 2 jars of marbles, where one jar is black marbles and one jar is white marbles, and you talk just in general sense, the entropy of that compared to if you took the marbles and all mixed them all together, so there's randomly mixed black and white ones, the entropy of the mixed would be higher than the entropy of them separated, because the separated is more ordered. And so the fact of getting 2 4s out of 3 rolls is kind of more of an ordered situation because you've got two of the same kind of thing, and that's less likely to happen, but it's possible. So this question, there's the philosophical question about entropy. Entropy deals with what's called the second law of thermodynamics. First law of thermodynamics says that the energy of the universe is constant. So, say there was a big bang, the amount of energy in all the stuff that makes up the universe is the same as it was right after the Big Bang. But entropy has been increasing ever since that point. And so the question is, a biological entity like ourselves is an ordered, we not only are we ordered in that we can think, but we're ordered in that, our cells do stuff. It's like a machine. So how do you create something that's more complex when the entropy of the universe is continually increasing? It seems like you're going against the second law of thermodynamics to have evolution or evolution or just even the existence of us. So does anybody? What's that now? Yeah. So what's happening is if you look at the disorder of the sun and the planets and us, that is increasing with time. So the overall entropy is increasing. You can have localized decreases in entropy, but the decrease in entropy caused by us would result in a larger change in entropy of everything else to make sure so that everything together is increasing entropy in entropy. So that's why it doesn't violate the second law of thermodynamics, and that's why evolution is scientifically okay from a thermodynamic standpoint. Anyway, that's a little sidelight there. If you want to learn more about that, take physics or begin engineering. So, okay. Anyway, the answer was, let's see if anybody gave me an answer, 0.069, which is the correct answer. Okay. So what you would do is you take 3 things 2 at a time. You have the probability of success, which is 1/6. You square that because that's the number of successes. The probability of failure is 5/6. you raise that to the 3 minus 2 power, which is the first power. So we'll end up, and because this is 1 less than that, it's just the answer's 3. And then we have 1/6 squared times 5/6 to the first power. And when you do that, you get 0.069. So those are 2 out of, there's 4 possibilities here. You can get no 4s, you can get 1 4, you can get 2 4s, and you can get all 3 4s. So since we're talking about it, and it's not that much more of a calculation, I'm going to do the calculation for you, and then we'll look at the results. So probably question A was what is the probability of getting 0 4s? And I don't know why those are italicized. Okay, so 0 out of 3 rolls. You would take 3 things, 0 at a time. The probability of success is 1/6. You raise that to the 0 power, and you take 5/6 raised to the 3rd power. And anything taken 0 at a time is 1, and any number raised to the 0 power is 1. So we just end up with 5/6 to the 3rd power. So 5 divided by, oops, turn my calculator on. 5 divided by 6 raised to the 3rd power is, I'll do this right, 3rd power is 0.5787. So that's the probability of 1 4, or 0, sorry, of not getting any. Out of 3. And then part D was probably 3. So you get 3 4s out of 3 rolls. That's the least likely thing to happen. And so that's going to be 3 things taken 3 at a time, 1/6 raised to the 3rd power, and 5/6 raised to the 0 power, because it's 3 minus 3. So I left this step out. I just gave you automatically. And the 3 things taken 3 at a time is 1. We have 1/6 to the 3rd power, and we have any number raised to the 0 power is 1. So we just take 1/6 to the 3rd power, and the probability of getting a 4 3 times in a row is 0.00463. So that's probability of 3 4s out of 3. So if somebody rolled a dice 3 times, got the same number 3 times, you would be very suspect of what's going on. So if you take all of these probabilities that we've calculated and you add them together, so the first calculation was 0.347. The second case, that was 1 out of 3. 2 out of 3 was 0.069. The probability, that's 0.069. The probability of getting no 4s would be 0.5787. And the probability of getting all 4s would be 0.00463. And if we add those numbers together, 0.347 plus 0.069 plus 0.5787 plus 0.00463, you get almost 1. And the only reason we don't get 1 is because I rounded off. So that's approximately equal to 1. And that's what it makes sense, that all the probabilities have, if you add the probabilities of each option together, you should get 1, because you're certain to have one of these 4 situations. So here's I don't know if it has anything to do with math, but I have to say a political thing, a little news snippet. So there's an advisor at the White House, 31 years old. He's been a anti-liberal person for a long time, and this weekend he said that it's well known that thousands of people were bused from Massachusetts to New Hampshire so that the Democratic candidate could have won. Even though the Republican chair of the election committee says that's a bunch of crap. Which, you know, if anybody had heard rumors, that would be the guy that would heard rumors, which he hadn't heard any rumors of anything like that going on. Besides the fact that if you think about thousands of people being bused, that would be 40 people on a bus, that would be 25 buses, so you're talking about 50 to 75 buses that somebody has hired and they paid somebody. And the fact that nobody has come forward and said, oh yeah, I rented out, my bus company bussed all these people, or you know, it's such a crazy claim. I don't know why people do that, but people will lie and people will believe lies. It's unbelievable sometimes. So use your brain sometimes. It's like here, you know, if you had somebody played a game and you got the same number 3 times in a row, and you look at the probability of that happening, this is 4.4%, which means it would happen 1 out of every, let's see, it would happen once every 200 times you would roll the dice 3 times. So when something doesn't seem right, don't just accept it as truth, both from a mathematical and a citizen standpoint. Okay, well, I already just did that part. Okay, let me, before we answer this question here about the free throws, I was going to explain where does this formula come from? So I'm going to use an example using free throws again to show you how you can figure out the answer the long way, and then how the formula is sort of a shortcut way of answering the same question. So the question I have is, what's the probability of making 1 free throw out of 3? And we know how to do that. We just, using the formula, we would say n is equal to 3, x is equal to 1, the probability of success is 0.7, and the probability of failure is 0.3, and we plug it in the formula. But if you think about it in a more simple scenario, is if you make 1 free throw and you miss 2 free throws, there's 3 ways that happen. You can make the first free throw and you can miss the second 2. You can miss the first one, make the second, and miss the third one, and you can miss the first 2 and make the third one. So to calculate the probability of each one of those 3 things happening, you use the let me show you back. Let me save this for a second. Let me open up section, was it 3 or 2? I think it was section 2. Let me open up that. No, section 3. So that was and. So events involving and. We have this conditional probability thing, but one of the key things here is if the events are independent, which is what's happening in this case. It's not based, the guy's ability is not based on what he did the previous shot. It's dependent upon his skill level. So those will be shooting free throws. We're going to consider them to be independent events. So the probability of 2 events happening, A and B happening, is the probability of event A happening times the probability of event B happening. And if you had 3 independent events, it would be the probability of event A happening times the probability of event B happening times the probability of event C happening. So to find the probability of things happening using the and words. And even though if we go back to here, the problem doesn't say anything about and, but it is, you can think of it as an and question. So it's saying, what's the probability of making one free throw out of 3? It's the probability of making, in the first scenario, it's the probability of making 1 and missing 2 and missing 3. So it is using the word and therefore you multiply the probabilities together. So the probability of making the first free throw is 0.7. The probability of missing the second free throw is 0.3. And the probability of missing the third free throw is 0.3. So you multiply those together. So it's a 0.063 probability that he'll make the first and he'll miss the second 2. And then you can look at the other 2 scenarios. So we have the second scenario where they make the second shot but miss the first and the third. So to find the probability of that happening is you take 0.3 probability of missing the first, 0.7 probability of making the second, and 0.3 probability of missing the third. You multiply those together, you get 0.063 again. And finally, when you make the third shot, miss the first 2, the probability of that happening is probability of missing the first times the probability of missing the second times the probability of making the third. You get 0.63. So if you look at the formula, this number is how many different ways I can make one free throw, or whatever the thing is. If it's getting 2 out of 3 fours, I can have the 4 being the first and the second roll. I can have it being the second and third roll. I can have it being the first and the third roll. There are 3 possibilities. So this tells you how many of these arrangements there are of getting the required number of successes. And then each one of these, you can see, has the same numbers. They're just in a different order. So we have the number of successes, which is 1 points, and you take the probability of success. So in each 3 of these formulas, there's only 1.7, and there's 2.3. So we can combine all those together into this formula. So that's where it comes from. It's looking at the number of arrangements of successes and then figuring out if you have multiple steps in whatever thing you're looking at, you reflect the number of the probability of successes and the probability of failures, and you get the final answer. So that's where it all comes from. The book just says here's the formula. That kind of bothered me. Okay. Did we do this one last time? We must have, because I've got it written down. So I'm going to let you do one more. I'm going to give you a similar problem because I usually put something like this on the test. So let's make sure you know what you're doing. So let's say we have Shaq. His free throw percentage is 0.40 or 40%. What is the probability of him making 6 out of 7 free throws? So remember, the formula is probability of X successes out of N trials is equal to N things taken X at a time, probability of success raised to the X power, probability of failure to the N minus X power. So look at that problem, see if you can figure out what X, N, P, and Q are, and then plug them into the formula and see if you can get me an answer. Let's look back at your, and if you look over here, this was 3 out of 3, so that you can kind of should be able to sort of figure out what goes where. So for you guys online, if you can give me an answer when you get one. It's kind of like, thinking about basketball free throws, it's sort of like basketball in general, because, you have upsets sometimes, and why do they, it's because, one team shoots much better than they normally do, and the other team shoots much poorly than they normally do, and so there's, you see upsets all the time. There's some experimental probability that they're going to win, but even a good team can be beaten by a mediocre team every once in a while. Or even a golfer, that's the problem. When you play golf, you do one good round, you think, oh, what did I do right? And then you overthink it, and then you screw up the next time. And then you get frustrated. How's your class going? It's okay? Is it? Yeah. Yeah, Mr. Sass is tough. Pardon me? Oh, is it Eli in your chemistry class too? Oh, you don't have him. Mr. White. Why is that? Oh, really? Oh, okay. Okay, yeah, I guess I know enough about Breaking Bad. Why Mr. White? Or Dr. White, I guess. Does anybody have chemistry? Anybody taking chemistry? Yeah. How's it going? Right. Okay, let's see if anybody's got an answer online here yet. 0.017. Is that what you guys get? Anybody get 0.017? No? Oh, you're waiting for me to do it? Well, you're going to have to figure it out one of these days, because you're going to have a test problem like this. Don't wait for me to do it all the time. I'll help you out this time. So, 7 trials, 6 successes. The probability of success is 0.4. We have 6 successes. The probability of failure is 0.6. And we have 1 failure. So this is 7 minus 6. Again, because this number is 1 less than that, it's just 7. I chose it, so I didn't have to calculate it. So then you have 0.4 to the 6th power and 0.6 to the 1st power. And then if you plug that in your calculator, you get 7 times 0.4 to the 6th power times 0.6 to the 1st power, which is just multiplied by that, and you get 0.0172, which is what somebody got. It's probably Harmony. And let's see, everybody else. Melissa, yeah, I'm not sure what. Anyway, do you guys see where you made your mistake for? So let's do another one. We're going to try this again. So let's think about what's that guy's name? Reddick, J.J. Reddick. Okay, on the other end of the scale. So he's a good free throw shooter. So J.J. Redick has a free throw percentage of he probably shoots 90% or 0.9 probability. What is the probability of him making only 3 out of 8? So n is equal to n is the number of trials. So how many trials do we have? 8. Okay. How many successes do we have? And what's the probability of success? Yeah. What's the probability of failure? Okay. So now we can just plug it into the formula. Probability of 3 out of 8 is going to be 8 things taken 3 at a time. Probability of success is 0.9. You raise that to the 3rd power. Probability of failure, you raise that to the 5th power, which is 8 minus 3. Now, in this case, you're actually going to have to calculate this because it's not one of the easy ones. So see if you can remember how to do that. I'll write the formula down for you just in case you forgot what it is. So the formula for figuring out n things x at a time would be n factorial divided by x factorial times n minus x factorial. So let's do that first. So for you guys online, if you can tell me what you get when you finish that off. Okay, so I've got a number. Okay, let's see if anybody's got an answer here. So Harmony says 56. Anybody gets 56? Yep. Okay, I got 56. So what I did, rather than I did the shortcut where you take 8 times 7 times 6 divided by 3 times 2 times 1. That's because whatever this number is, then you go down. You have that many numbers in the numerator and the denominator. Here you start at 8, and here you start at 3. So that ends up being 56. Okay. So now the probability is going to be 56 times 0.9 to the 3rd power times 0.10 to the 5th power. So let's see what you get there. Do you have an answer? What is it? 0.00040824. And that is right. Yeah, it's a small number. There's 2 reasons why it's a small number. One is it's very unlikely that a 90% free throw shooter to only make 3 out of 8. That's just not something they do. And secondly is that, the more trials you have, the more options there are. So the probability of one particular option out of the options in this case, there's 0, 1, 2, 3, 4, 5, 6, 7, 8, instead of maybe just 2 or 3 options. But So this says that if he shot 10,000 free throws, is it 10,000? 100,000 free, 100,000. That seems. Let me take that. Okay, so 0.00004. So no, yeah, three zeros. And if we multiply that by 10,000, what does that come out to be? 4. Yeah. So if he shot 8 free throws 10,000 times, 80,000 free throws. Of those 10,000 times that he would shoot 8 free throws, is only 4 times out of that he would miss, only make 3 out of 8. It's very unlikely for something. Again, you could, if some guy like that came to the line and did something like that, you would either think that's a very rare event or he just did it on purpose. You know, somebody that good cannot. It's very unlikely for them not to do reasonably well. Okay. The last problem we're going to do here in this section is this one. It's in your book. I don't remember what number it is, but it says it is known that a certain number of prescription drugs produce undesirable side effects in 35% of all patients who use them. Among a random sample of 8 patients using the drug, find the probability of each event. So the first one is that none have the undesirable side effect. So the way we would do that is, figure out what we need to know what N is, we need to know what X is, we need to know what P and what Q are. So in this case, I'm going to say a success, I'm just going to have to define success, is an undesirable side effect. Okay, it sounds wrong, but again, success is all relative. Undesirable side effect. So what's the probability of having an undesirable side effect? What's the probability of successfully having an undesirable side effect? 0.35, and therefore the probability of not having an undesirable side effect is 1 minus that. Okay, so that's good. 8 patients. So what would the 8 correspond to? Yep. And if none have undesirable side effects, that's 0 successes, right? So that's 0. So now that we've figured those things out, the rest should be a piece of cake. So 0 out of 8. So I'll let you set up the rest of it and see if you can calculate an answer. It's somewhat easy because one of the subscripts is 0, so we know what that is in terms of combinations. And also one of the exponents is going to be 0, so you only have to and the formula's down here if you forgot what it is. Oh, and I hear the answers anyway. I didn't realize they were over there. It's also easy when they give you the answer. At least I can give you the answer. I'll give you the input. The hardest part is probably to remember that success is always relative, depending upon what the question is. Okay, let me see what I get here. So we have 0.35. Where's the 8 power? Yep. Oh, you're right. Thank you. So this is 0, and that's 8. You're good. Just keep me straight. Okay, so it's just 0.65 to the 8th power, which is 0.0319. And you could figure out the probability for 0, for 1, for 2, for 3, for 4, you know, in terms of the number out of 8. And if you did that, you would get 9 numbers, and then you would you could get a probability distribution out of that. What do you think the most likely number of people out of 8 to have the side effect would be? If you picked a sample of 8 people, how many people out of that 8 would you think would have a undesirable side effect? Based on yeah, that's what you're supposed to do. Okay, so your most likely answer is you just take the number of trials times the probability of whatever is happening here. So you take 0.35. So 0.35 times 8 is 2.8. So that's, you'd probably say 3 out of. So if I were to do, yeah, they wouldn't do that. Well, I don't know. If you take chemo, everybody has. Yeah. Yeah, because you look at side effects for things, you're like, how the heck did that happen? 3 people out of, yeah. Right. Yeah. So if you did 3 out of 8, which is actually is that what we did? No, we did 0 out of 8. If you did 3 out of 8, that would give you, I wouldn't say, I was going to say most likely it is. That's going to be the one that has the highest probability of happening. And as you go away from that number on either side, it's going to drop off. So 0 out of 8, probably 8 out of 8 getting side effects is going to be more unlikely than getting 0 out of 8, just because it's just from a symmetry standpoint. Okay, so let's do this one here. Let me delete this page. I've got extra in here. So what about more than 2 side effects? So that would be 3 side effects, 4 side effects, 5 side effects, 5 people, 6 people, 7 people, 8 people. Is there an easier way of doing that? Right, yeah. So the easier way of solving this problem would be the probability of more than 2, which would be 3, 4, 5, 6, 7, and 8, would be to take the probability 1 minus the probability of getting 0, 1, 2, or 3. So this is using the complements principle, because we know that we add those all together, we get 1. So this one's easier because there's only 3 calculations to do, and there's really only 2 now that I've already done the first one. So why don't you go ahead and calculate these other 2. So what we need is the probability of 1 out of 8, and we need the probability of 2 out of 8. And what we'll do is, to get this, you just add them together, because this is the probability of having 0 or 1 or 2. So since we're using OR, you add the probabilities together. When you have an and in this case, and makes no sense. You can't have 0 and 1 for this and 2 for the same group. So it's an OR question. So use the same formula. The only difference is that, you know, this will become 1, and this will become 1, and this will become 7. So you've got 1 success, 8 failures relative to how we defined it. So this one's also easy. That's 8, right? The only one we have to actually do a calculation for the combinations is and I don't know why I put 2 there. I was thinking the next thing I was doing. Okay, so that's some number. And then we'd have 8 things, 2 at a time. 0.35 squared. I did it again. Oh, yeah, that's right. And 0.65 to the 6th power. So see what you get. And then we'll add this number here, plus that number there, plus that number there. That'll give you this probability of having 1 side effect, 0 side effects, or 1 side effect, or 2 side effects. And the numbers should get bigger as we move towards 3. That number seems too big. But maybe it's true. This is 20. Do you get 28 for that? Yeah. Seems like a big number. So all I do is once I get the 3 numbers, which are 0.0319, 1.137, 0.259, you add those together. And you subtract it from 1. And so I get 0.572. So that's the probability of getting more than 2 side effects. Or not more, more than 2 people out of 8 getting side effects. It must drop off pretty rapidly because this probability is 0.259, so the next one should be 0.3 something, and and if you add that to 0.57 something, then that's almost, it's getting close to 1. Did you get these same numbers? Yeah, that bothers me a little bit, just because it must drop off rapidly when you get, because they have to add up to be 1. But you got it right, so you got the same answer I did, so I think we did it right. There's more problems. Did I assign this yet? I think it. So next, well, we're not finished yet, but we'll do some. Got 2 more problems we'll look at, but the next section is pretty short, so we'll have plenty of time to finish that up next time. Pardon me? No. It's Valentine's Day, but Do you have a Valentine? Yeah. They just die anyway. It's too practical. It's okay, good. Gee, he sounds like he did better than I do. I was telling my other class. So when you've been married for 38 years, like we have, yeah. Well, usually I do buy a card that's, I'd buy a nice card. But we were at Walmart the other day, and Martha said, "Let's go over to Dollar Tree. Let's buy our Valentine's there, because like flowers, you read them once, you throw away. What the heck?" And if your wife says that, you're like, okay, that's good, save some money. But I did buy her a present, which she didn't expect, which was I got her a gift certificate for a pedicure, and she was happy about that. So, because Candy is kind of, she doesn't. Yeah, that's the problem with Candy. Okay, number 44. At a large university, 90% of all students have their own personal computers. If 5 students are selected at random, find the probability that exactly 3 of them have their own computers. So, what is N? Well, 5, because that's, we don't use probability, so we only have 3 numbers here. We have 0.9, we have 5, and we have 3. So this is 5, X is 3, P is 0.9, Q is 0.1. Okay? So we stick that into our formula. Probability of 3 out of 5. You take 5 things 3 at a time. Probability of success raised to the 3rd power. Probability of failure raised to the 2nd power. And you get some answer. You get some answer. This 0.9 is P. So that's always the probability, either a point. The power is X. So this number is always the same as that number. K. Oh, in the formula? Oh, really? Oh, this thing looked like a K. Oh, sorry. There we go. Yeah. So what is it? 1, 5. I think it's 10, if I remember correctly. This is 10. So you take 10 times 0.9 cubed times 0.1 squared, and you get 10 times 0.9 cubed times 0.1 squared, and I get 0.0729. The most likely answer is 4.5. You take 0.9 times 5, which would give you 4.5. So, 4 or 5 people. It's less likely to have 3 people or 2 people, 1 person, 0 people. Okay. And then the last one here, if it is known that 85% of all orange trees will survive a hard frost, then what is the probability that at least half of a group of 6 trees will survive such a frost? So, N is equal to something, X is equal to something, P is equal to something, Q. Okay. So what do you think N is? What is X? 3, yep. Half of 6 is 3, yep, good. 0.65, 0.35. So the probability of 3 out of 6 surviving, which is surviving is what do we call it now? We called it, I've forgotten the word now. Success, yeah, it's a success. In this case, it is a success. 6 things taken 3 at a time, 0.65 raised to the third power, 0.35 raised to the third power. 6 minus 3 is 3. So this number is always that. This minus that gives you that number. And 6 things taken 3 at a time. I'm using my shorthand. 6 times 5 times 4 divided by 3 times 2 times 1. And so we plug that in there. And let's see what we get. So this number is what? 30 times 4, which is 120. 120 divided by 6, which would be 20. So it's 20 times 0.65 cubed, 0.35 cubed. Plug that in. 20 times 0.65 to the third power times 0.35 to the third power. And it's 0.235. So that's the probability that half the trees will survive. That's based on the average of 65. So again, the most likely would be 0.65 times 6, which is about 4 probably, right? 0.65 times 6. So you take the probability of success times the total number of trials. The most likely outcome is 3.9, which would be about 4 trees would survive. Okay. So 5 minutes was given to you for Valentine's Day. It's hard to see what that number is because it gets chopped off, so I'm assuming it's... Yeah, the test is on Tuesday. I haven't got it yet. I will by before the weekend.